I'm Ranga Karnam. I'm 10x certified in AWS, Azure, and Google Cloud as well. Our courses are helping thousands of learners do their cloud certifications in AWS, Azure, and Google Cloud. In this video, let's learn AWS. We will take a simple example and understand all the different services which are present in AWS. We'll be exploring more than 50 different AWS services with this specific example. Are you ready to get on a ride to learn AWS? Let's get started. The example we are going to use is a very simple application, right? You have a front-end application which is talking to a REST API, which is fetching the data from a typical database. And you also have a reporting workflow. Let's not really worry about the reporting workflow right now. Let's start with thinking about how we can actually implement this specific front-end application talking to a REST API, talking to a database. This is typically called a full stack application, right? So how do we implement this in AWS? That's the first thing that we would start with right now. Now, let's start with focusing on the REST API part of it, right? You'd want to deploy a REST API to AWS. Let's say this is a Java application or a Python application or a Node.js application, which is part of your REST API. What do you need to run your specific REST API? Let's say you are running it in your data center. Typically, what you would need is something called a virtual machine. You would need some kind of compute to be able to run your application. This is what is called a virtual machine. Will just one virtual machine be sufficient? What if this virtual machine goes down? Your application will go down. And that's why in the cloud, typically you will not just have one virtual machine. What you'll have is a group of virtual machines. So you'll have a group of virtual machines where you would deploy your application to. And when you have a group of virtual machines, what do you need? You need to be able to load balance between them. So you need to set up a load balancer to load balance the requests between all these things. So you need to have something on top of this. This is nothing but a load balancer. So all the requests from the user would go to the load balancers, and then from the load balancer, they would flow down to your VMs or the virtual machines. On this virtual machine is where you can deploy your application. Maybe if it's a Python application, you would install Python and then deploy it in there. This is kind of a simple architecture you can get started with. And if you're implementing this kind of an architecture in AWS, what you can make use of is something called EC2, Elastic Compute Cloud. Elastic Compute Cloud is the compute service in AWS. And if you'd want to do load balancing, what you would need to do is to use something called Elastic Load Balancer. Elastic Load Balancer will help you to load balance between different EC2 instances. One of the things that we have seen in here is the fact that we would want to create a group of EC2 instances. We want to create a group of virtual machines. How can you do that? To be able to create a group of virtual machines, what you need to do is you would need to actually make use of a concept in AWS called auto scaling group. Typically, when I just need to create one virtual machine, EC2 is sufficient. Elastic Compute Cloud is sufficient. However, if I would want to increase the number of EC2 instances, if I would want to create a group of EC2 instances, that's when I would go for an auto scaling group. And you would use an Elastic Load Balancer to distribute the load among different EC2 instances which are part of an auto scaling group. So that's how you can deploy your REST API to AWS. One of the things that you can do is you would want to increase the availability of your application, right? What if this specific VM goes down? If this specific VM goes down, your application also goes down. And you don't want your applications to be down. Your application should always be available to your users. How can you ensure that your applications, your VMs which are deployed, don't go together down, right? They should not go down, both of them together, all of them together, right? So that's the reason AWS provides you with concepts called regions and zones. What are regions and zones? Let's write them down. Regions and zones. What's the concept behind regions and zones? Typically, whenever you have an enterprise, maybe they have just one data center. If you deploy all your VMs to this data center, if this data center goes down, your application goes down completely. And that's the reason why you don't want to deploy your VMs to just one data center. You might want to deploy your VMs to multiple data centers, and you don't want to deploy to data centers in a single region, right? This might be, let's say, in London. You don't want to deploy just to London. If you want your applications to be highly available, you'd want to be able to geographically distribute them as well. Maybe you'd want to set up something similar in New York as well. So you'd want to have something in London, something in New York, something in Sydney, something in Mumbai, and you'd want to create your VMs in there. So this is just the concept of regions and zones. In AWS, each of these, London, for example, New York, for example, maybe there are multiple other regions as well. AWS offers around 26 different regions around the world. What these regions allow you to do is to deploy these VMs in different parts of the world. Thereby, your applications don't go down. Even if the entire geographic location is going down, even if your data center completely goes down, your applications are still available. So what a ASG allows you to do is to distribute your EC2 instances across multiple zones. So in a single region, you can deploy your EC2 instances across multiple zones. Now, one of the things that you would have been seeing until now is the fact that there is a lot of complexity that is associated with setting up a simple thing. All that I'm doing in here is I want to set up a REST API for a Python application. And already we are talking about a lot of different concepts related to AWS. We are talking about EC2 instances, ASG. We are talking about ELBs. We are talking about regions, zones. You might be wondering, why do I need to worry about all this? Do cloud providers make it simple for me? Yep, the cloud providers do make it simple for you. And that's where you can go for some of the managed services which are present in the cloud platforms. Instead of creating EC2 instances manually, instead of creating auto-scaling groups, instead of creating elastic load balancers, you can tell AWS, hey, AWS, this is the code I would want to deploy. If the number of requests come in, if a high load of requests come in, then increase the number of instances. If there are less requests coming in, then decrease the number of instances. Can you do that automatically for me? I don't want to worry about installing Python. I don't want to worry about installing my application on each of these VMs. That's a lot of work for me. I don't want to worry about those operational details. I'll just give you something like a jar or a WAR file or a Python deployable unit or a container image. And can you deploy that for me automatically? And can you manage everything for me? That's where managed services come into picture. The managed services which are present for compute in AWS, if you just want to set up a simple setup like this, if you want to create a load balancer, distribute the load between multiple EC2 instances, in those kind of situations, you can go for this specific service in AWS called Elastic Beanstalk. With Elastic Beanstalk, all that you need to specify is, hey, AWS, can you take this piece of code and can you deploy this in such a way that this is deployed to these many instances? You can also configure auto scaling. Basically, you can say increase the number of instances based on the load and decrease the number of instances based on the load as well. So that's Elastic Beanstalk for you. It's a managed service for compute in AWS. You don't really need to worry about setting up the load balancer, setting up the auto scaling groups, setting up the metrics for it, setting up the EC2 instances. You don't need to worry about what runtime needs to be available on the EC2 instances. You don't need to worry about that. All that you need to do is to go to Elastic Beanstalk and say, I would want to deploy a Java application. Here is the jar or a var. Here is the container image for it. And Elastic Beanstalk would run it for you. So if you have a simple application, simple Java-based, Python-based, Node.js-based, or any other language-based application, you can use Elastic Beanstalk to deploy it to AWS without worrying about managing it. You don't need to worry about availability, scalability. You don't need to worry about increasing the number of instances and things like that. Elastic Beanstalk takes care of everything for you. One of the other important evolutions in the last few years is the evolution to Docker containers, right? Instead of actually trying to create a VM with multiple layers, right? So whenever we are trying to set up an application in the VM, there are a lot of things that you need to set up. First is the underlying infrastructure of the VM. Let's not really worry about it. On top of it is where your OS is. On top of it is where your application runtime. If I would want to have Java application, then I would need to create a Java runtime. And on top of it is the code. You'd also need to be able to configure environment variables and things like that, right? So deploying an application typically involves a lot of different steps. So if I want to deploy something to a VM, there are a lot of manual steps involved. And to avoid that, we started going towards containers. So we started going towards a container image. So instead of doing this on the VM, what we can do is we can create a container image. And the container image contains the OS, it contains the runtime, it contains the configuration you'd need, and it also contains the deployable unit or the code which you would want to be able to run. And once you have a container image, you can go ahead and run this anywhere. You can run it on your local machine, you can run it in the cloud, you can run it on the data center. That's the concept of containers. And Docker is one of the most popular container runtimes, right? So Docker specifies a format where it specifies how your container image should be structured, and also it specifies the standards for the container runtime. So it tells this is how your container runtime should be as well. And in AWS, if you have Docker images, you can use Elastic Beanstalk to run them as well. So Elastic Beanstalk not only supports jars, vars, Python applications, and things like that, you can also give it a container image. And it would ensure that it is deployed in the right way, in an efficient way. And it also enables auto-scaling. It enables easy operations and all that stuff. However, let's say you have a microservices architecture where you have a number of small microservices which are talking to each other. Some enterprises have 10 microservices, some enterprises have 100 microservices, some enterprises have thousands of microservices, right? In that kind of a scenario, what you can do is you can go for something more than just a simple managed service. When you have just one application to manage, Elastic Beanstalk is a really good thing to go for. However, when you have multiple applications, multiple microservices to manage, that's when you would need something complex. Maybe your REST API is not just one REST API. You have a number of REST APIs which are being exposed. In that kind of situations, you can go for container orchestration solutions which are present in the cloud. If you look at container orchestration, one of the most popular container orchestration tools, do you want to guess that? Yep, it is Kubernetes, right? So Kubernetes is the most popular container orchestration tool today. And in AWS, if you'd want to run Kubernetes, you can make use of Elastic Kubernetes service. And AWS also provides its own container orchestration service. It's called Elastic Container Service. Actually, Elastic Container Service is something which came in even before Kubernetes. So a lot of customers are making use of ECS, especially AWS customers are making use of ECS, and some of them are actually shifting towards Kubernetes as well. So AWS offers both these options, Elastic Container Service and Elastic Kubernetes Service. In Elastic Kubernetes Service and Elastic Container Service, what you need to do is you need to first create a cluster. And in the cluster, there are multiple nodes. And to this cluster, you can deploy your applications. That's basically the concept of container orchestration. You create a cluster, and you can tell the cluster, I would want this many instances of this specific container. Microservice 1, 5 instances. Microservice 2, 6 instances. Microservice 3, 10 instances, so on and so forth. In EKS and ECS, you need to manage the cluster. So you need to take care of adding nodes to the cluster, removing nodes from the cluster. All that would become your responsibility. However, if you want to be able to run something like this in a serverless way, you don't need to worry about managing the cluster at all. In those kind of situations, you can go for Fargate. AWS Fargate is a serverless version of ECS. So you can run ECS in a serverless way. You can run a container in a serverless way by going for Fargate. So until now, to run your REST API, we talked about multiple options. The first one which we talked about is to create an Elastic load balancer, create Elastic compute instances, EC2 instances, and use a ASG to create a group of EC2 instances and use ELB to distribute load between them. That's the first option. However, it involves a lot of maintenance, a lot of headache for you. Instead of that, you can go for Elastic Beanstalk. If you have a lot of applications that you would want to manage, maybe you'd want to go for container orchestration solutions. That's when you'd go for EKS and ECS. In the last couple of decades, there is one more approach which is becoming popular. Whenever we talk about applications, we talk about how to deploy them, how to create the cluster, how to create a load balancer, how to create multiple instances, how to install applications on the server, how to install a runtime, how to deploy the application there, and all those kind of things. What if you don't need to worry about servers? So do not worry about servers. That concept is what is called serverless. In serverless, you don't worry about your servers. All that you would do is you would give a piece of code. So you'd give a piece of code and you tell AWS, hey, AWS, this is a piece of code. I might get 10 requests. I might get 10,000 requests. Handle it for me. I don't really want to worry about it. That approach is what is called serverless approach. And in AWS, the most popular service to be able to do that is AWS Lambda. If you look at the serverless world, I would say in the serverless functions world, AWS Lambda is the #1 service. I would say almost 80% of the customers who are making use of serverless functions are running them using AWS Lambda. As we talked about earlier, when you're going for AWS Lambda, you don't need to worry about servers. All that you need to give AWS is this is the code, this is the runtime I would want to make use of, and you'd be able to scale it to whatever limits you would want. AWS Lambda can handle that for you. If there are 10 requests, it can handle that for you. If there are 10,000 requests, it will handle that for you. And the other important thing is you'll pay by volume of your requests. Let's say there are 10,000 requests. That's what you would pay for. Let's say there are 0 requests coming in. You don't need to pay anything at all. So if you'd want to be able to run your REST API in a serverless way, that's when you would go for AWS Lambda. So until now, we looked at some of the managed services for hosting your compute related things, for hosting your web application, for hosting your REST API, and things like that. The options which we looked at are EC2, Elastic Load Balancer. We also looked at Elastic Beanstalk. You can go for container orchestration with EKS, ECS, or you can go for serverless container option, which is Fargate, or you can go for the serverless function option, which is AWS Lambda. I hope this was very, very useful for you. Let's now go into the other world. Let's go into the database world, right? Even running databases is not easy. A lot of people think databases are easy to run. However, databases are very, very difficult as well. Let's say I would want to install a database on a specific VM. I would need to first set up a OS. I would need to set up the database runtime, Oracle or whatever. Then I would need to create my database and then create my data, right? So managing a database is also not easy. And doing operations for databases also is very, very tough. If you want to take a backup of this, if you want to ensure point-in-time recovery, right? Let's say some problem happened and I would want to be able to recover to a state my database was in yesterday. That is what is called point-in-time recovery. Your databases typically need point-in-time recovery. And you don't want to lose data. So you'd want high durability for your databases. And in addition, you'd want high availability. There might be a lot of applications which are talking to your database, and your database should be highly available. Setting up high availability, setting up scalability, setting up operations, everything for your database is very, very complex. And that's the reason why you don't want to create an EC2 instance and set up a database on it. If you create a EC2 instance, install database, set it up, you need to also take care of availability. You might want to create another database, another copy of it in maybe another zone or another region. And those kind of things become really, really complex. You don't really want to be doing that when you go to the cloud. That's where you would go for managed database services. So just like there are managed compute services, there are managed database services also present in the cloud. These managed database services help you to easily create databases and run them in the cloud. Whenever you want to create a database, the first option that you need to think about is, do I want to create a SQL database or do I want to create a NoSQL database, right? I'm using SQL as an abbreviation for relational databases, right? So you might want to create a relational database, tables, relationships, foreign keys, primary keys, and all that fun stuff. Or you'd want flexibility. I would want huge scalability, right? That's when you go for NoSQL databases. When you go to relational databases, there is perfect structure. So there is a structure in which you need to create your data. There are proper relationships. It is not really flexible. And relational databases typically can scale only to a limited extent. However, NoSQL databases don't have any structure. Typically, they are very, very flexible with this structure, but they provide you with high scale. So depending on your specific use case, you would want to go for a relational database or a NoSQL database. If you have a banking application and you are managing banking transactions, in those kind of situations, transaction management is very, very important. In those kind of situations, you would go for relational databases. Let's say I have a social media application, or let's say I have LinkedIn or Twitter or Facebook. In these kind of situations, transactions might not be so important. Little bit of inconsistency in the data might be okay. If I'm posting a tweet, it might not go at the same time to all the people. That's okay. In those kind of situations, we would go for NoSQL databases. When we go for NoSQL databases, we need high scale. We would want millions of transactions per second, right? So that's the situations in which you go for NoSQL databases. In AWS, the most popular relational database is RDS, Relational Database Service. If you want to run MySQL or Oracle or SQL Server, that's where you'd go for RDS. There is another option which is very, very popular in AWS, which is called Aurora. It's also called Amazon Aurora. So if you want a regional database, and if you want to scale only to a certain extent, maybe the maximum typically allowed is 64 terabytes. So if your data fits in with these requirements, and if you just want a regional database, then you can go for RDS with MySQL, or RDS with PostgreSQL, or RDS with SQL Server or Oracle. But if you want a global relational database, in those kind of situations, you can go for Aurora. This provides you with 99.999% availability, which is considered to be really, really, really high. It provides transactions, it provides high scalability, and all the things that you would typically need from a relational database. So that's one of the options for your database. So depending on the type of application you are creating, you might choose between relational database or NoSQL databases. If you go for relational databases in AWS, you have the option to go to AWS RDS, or you can go for Aurora. Now, let's say you want to go for a NoSQL database for your transactional application. Let's say you are creating a social media application. For you, consistency is not so important, but scale is very, very important. You would want to be able to scale it to millions of transactions per second. In those kind of situations, you would go for NoSQL databases. And typically, the database you would go for in AWS is DynamoDB. DynamoDB is the most popular NoSQL service in AWS. This is something called a document database. You would store your data as JSON documents, and you can actually create indexes on specific elements of your documents, and you also have a lot of flexibility. A specific document might have certain details. A specific another document in the same table might not really have the same amount of details. So these are some of the important database options when it comes to transactional applications, right? Transactional applications make small changes like small updates, small deletes, ads, and things like that. These are typically online applications. A web application is typically a transactional application, right? A shopping application or a banking application. These are all transactional applications. Now, are there just transactional applications? No. You might have some reporting applications, some business intelligence related applications as well. That's when you would go for analytical databases. For example, one of the most popular analytical solutions is something called Hadoop, right? You can run Hadoop in AWS as well. And AWS provides its own solutions as well. In AWS, if you want to run analytical database, one of the recommended options is to go for Redshift. AWS Redshift is one of the popular ones. You can actually have petabytes, huge volumes of data, and you can actually run compute or queries against this huge volume of data with very, very high performance, right? Whenever we talk about a relational database or actually a transactional database versus analytical database, the difference is in terms of the operations which are performed. In the case of a transactional database, there would be a small amount of large number of transactions. right? So what we are talking about in here is there would be small updates. Maybe one row is updated, or 3 rows are updated, 10 rows are updated, or 5 rows are inserted, 4 rows are deleted. So these are the kind of operations which are performed on transactional databases. However, when we are talking about analytical databases, typically you'll load the data in bulk. You will take all the data from a transactional database and load it in bulk into the analytical database. But what you would be doing from here is running a lot of queries, a lot of very, very complex queries. You'd want to get intelligence. So when it comes to analytical databases, you have one-time loads, maybe once a day or once a week or things like that. And you would have huge volumes of reads. You have queries which are running, which are very, very complex. And that's the reason why analytical databases are optimized for reads, huge volumes of reads across huge volumes of data. And in AWS, the recommended option is Redshift. You'd go for this when you have analytical workloads that you'd want to run in AWS. Now, how do you get the data from your relational database or from your transactional database into your analytical database? That's when you can go for a data pipeline. So AWS provides a service called AWS Data Pipeline. AWS Data Pipeline can read data from your database, from your transactional database, and load it into an analytical database as well. And AWS also provides business intelligence solutions. So you can use something like AWS QuickSight or something of that kind to read from your analytical database and get intelligence to be able to run queries and all that stuff around this, right? So after focusing on the compute part, this is basically REST APIs in the compute part. We shifted our attention to the database part. We talked about how you can run databases in AWS. We talked about relational databases, RDS Aurora, and we talked about NoSQL databases. One of the most popular ones is DynamoDB. And we also talked about analytical databases, Redshift. You can also run Hadoop using a managed service in AWS as well. And we also talked about business intelligence. For example, something like AWS QuickSight. Now, let's shift our attention to the front end, right? So until now, this is the part which we did not really talk about. So let's say we have a web application that we would want to serve, a React application or a Angular application. That's what we would want to serve in the front end. One of the options you have is to use EC2 instances as well. So over here, you can create an EC2 instance. You can put the web application there, and you can also set up load balancers to serve the static application which is deployed onto EC2 instance. Or you can actually set up a web server on the EC2 instance and serve it from your Elastic Load Balancer. So that's one of the options you always have when you want to serve a front-end application. But it, again, is a lot of operational details. And that's where AWS provides another service which is actually not related to running applications at all, but it also helps you to expose a static website. Now, before we get there, let's talk a little bit more about storage services which are present in AWS. Why do we need storage? Let's say I have a virtual machine, right? I have a virtual machine. I would want to attach a hard disk with it. I would want to attach a simple hard disk with it. What is the service you can make use of in AWS? In AWS, to create virtual machines, you can make use of EC2. And when you are creating a virtual machine with EC2, what happens is a hard disk is automatically created for you. And the service which is used to create this hard disk for you is called Elastic Block Store. So Elastic Block Store is the service which is used to create a hard disk and attach it with your VM. You can also create file shares. So if I would want to create a file share and share it between multiple EC2 instances, maybe an instance from my data center, in those kind of situations, I can go for something called EFS, Elastic File Store. So what we are talking about over here are storage devices which are attached to your VMs. So there are a number of storage devices you have, and you can attach it with multiple VMs. Whenever we talk about Elastic Block Store, we are talking about something like a hard disk. A hard disk at a particular point in time can only be attached to a single VM. However, whenever we are talking about Elastic File Store, what we are talking about is something which can be shared. So this one, if you are creating using EFS, can be shared between multiple devices. Now, this is one kind of a use case where you would want to attach storage with your virtual machines. Let's talk about a few other use cases related to storage. Let's say you have users who are uploading files to a website, and you'd want to store all those files in a particular place. You can use a database, but databases are not optimized for storing files. Let's say these are large video files or large audio files or large images, things like that. So these are all objects. You'd want to be able to store these with a key value pair. So the value is the file itself, and the key is a unique thing you give to identify a specific thing, right? So when you want to go do some things like that, that's when you go for something called object storage. So in object storage, you can create buckets and you can store objects using key value pairs. So you can say this is the key, this is the value. And you can store text files, you can store images, you can store video files, audio files. Any kind of files can be stored in object storage using a simple REST API. So this provides you with a REST API, and you can use the REST API to upload objects, to retrieve objects using their keys and values. And object storage also provides a lot of other use cases. You can store archive files in here. If you are migrating data from, let's say, an on-premise to the cloud, you can use object storage as a temporary store. You can first load the data into, create an archive for your database, put it into object store, and from there you can load it into your specific database in the cloud. So there are a lot of purposes which an object storage can be used for. One of the other purposes which it can be used for is to create a static website. If you upload all your static files, your CSS files, images, your HTML content, all of them, if you create a bucket and upload it into an object storage, you can expose it from your object storage as a website. So once the content is there in an object storage, you can even expose a static website. And when it comes to AWS, this is the most preferred way of exposing a static website. What you can do is you can make use of S3. So you can use the S3, which is the object storage service. It's also called simple storage service. S3 is one of the actually most popular AWS services because it's one of the first AWS services as well. So you can use S3 and you can actually deploy your front end into a bucket in S3 and you can serve it from there. And if you want to actually give a name, let's say you'd want to expose it at a website. So I would want to expose it at www.in28minutes.com. Then I can make use of a service in AWS called Route 53. So Route 53 is the domain naming service in AWS. And let's say I would want to cache the content. This is static content which can be cached. In those kind of situations, I can make use of CloudFront. CloudFront can be used to cache and distribute your content to around the world, right? The content in S3, you'd want it to be available for users across the globe from different continents. What you can do to make latency lower is to distribute it across the world. And that's what CloudFront can do for you. So you can use CloudFront as a distribution mechanism for your static content to distribute it around the world. You can use Route 53 to name your website. Until now, we talked about a varied range of services which are present in AWS. We talked about REST API, which is your compute. We talked about different compute services. We talked about different relational database services, which are typically used for transactional applications. We talked about analytical databases as well. And we talked about business intelligence as well. And right now, in the last few minutes, we were talking about the front-end application, which is typically deployed to object storage in AWS, which is S3. And we also talked about how you can actually give it a name, www.in28minutes.com. You can do that in Route 53. You can buy a domain name. You can associate it with your content, which is present in S3. And we also talked about CloudFront, which is used to distribute your static content across the world so that users get low latency. So that's kind of at a high level, some of the important services we wanted to touch upon. Now, one thing which we did not really talk about at all is security, right? Security is very, very important. One of the most important things that you need to realize is the fact that AWS is a shared cloud platform. Whenever you make use of infrastructure in AWS, that infrastructure is shared between multiple enterprises. So if you are creating a VM, it might be on the same hardware as some other customers. So security is very, very important. you'd want to be able to separate the traffic which is going into your application from other applications which belong to other enterprises. Let's say I have a simple application which is talking to a database. The traffic which is going on between them will not be visible to outside world if you are running it within a data center. But over here in the cloud, we are running it in a cloud, and there might be other applications which might be deployed over here. And that's where we would want to separate the traffic out. We want to control the entire traffic which is going into your devices and to your databases. How can you do that? That's where you can go for a concept called VPC. So what we can do is we can create a VPC, virtual private cloud. Networking is a concept which a lot of us as a programmer might not be familiar with. Please bear with me. Understanding networking is very, very important when you go to the cloud, because we don't understand networking as well, right? When you go to the cloud, security becomes really, really important. Inside the data center, all the applications are belonging to one enterprise, so security might not be so important. But once you go into the cloud, security becomes really, really important, because we are making use of shared infrastructure. And the way you can actually implement security, the way you can actually control traffic which is going into your applications, is through these concepts called VPCs and subnets. So if you create a VPC, you can control all the traffic which is going inside the VPC and all traffic which is going outside the VPC. You can set up rules saying this traffic is allowed, this kind of traffic is not allowed, right? So basically, a VPC has rules, route tables, where you can define the different rules. And also, there might be different kinds of applications which are present in a VPC. Let's say this is a web application, and I would want to be able to access this from the internet. So there'll be users who would be accessing it over internet. However, this database, I don't want it to be accessed from the internet. I only want it to be accessed from other applications or from other devices which are part of this network only. So there are different use cases for different kinds of resources you create in a specific VPC. And that's where we can go for subnets. Subnets allow you to configure different rules for different things. So anything that you create within a private subnet. So let's call this a private subnet, and let's call this a public subnet. Anything you create in the public subnet can be accessed from the outside world directly. Anything you create in a private subnet cannot be accessed from outside world. You should either talk to them from another resource which is present in the private subnet, or you can talk to it from the public subnet. And you can configure rules to allow what is allowed. Actually, you can configure rules to decide what is allowed and what is not allowed as well. So you can separate resources which are present in the VPC into different groups by using subnets. You would put all the things which you would want to allow access from internet in a public subnet. You'd put all the things which you don't want to allow access from the internet in a private subnet. So typically, a web application, something you'd want to be allowing access from internet, will be going into a public subnet. And in the private subnet is where you'd put all the things like a database, for example, or any storage devices you don't want to allow access from outside. So all those things would be put inside a VPC. Now, you might be creating a number of resources in the cloud, right? You might also have your own data center. So you might have your own data center which is being made use of by your corporate. And you'd want to establish connection between different resources. So you'd want to be able to have your resources which are in your data center talk to resources which are present inside your VPC. How can you do that? That's where we go for a concept called VPN. VPN is over internet. So you establish a connection between your cloud, between your VPC which is present in the cloud, and your data center by making use of managed VPN in AWS. However, one thing to remember is that this traffic goes over internet, and that's why the traffic is encrypted using IPsec protocol. However, you might be thinking, hey, I don't want to allow traffic over internet. I would want to create a dedicated connection. In those kind of situations, you can also create a dedicated connection. This is called direct connect. So you can establish a direct connect from your data center to the AWS cloud, to the specific region where your VPC is present in. Until now, we touched upon some of the important aspects related to AWS. We talked about a lot of AWS services. Now, before we conclude, I'll talk about a couple of more AWS services which might be interesting for you. Let's say this REST API wants to talk to a queue. So you might have other applications which are listening on this queue, and they are consuming the messages which are coming in here. The popular queuing service in AWS is SQS. Amazon SQS is a queuing service. Typically, whenever we talk about applications, you'd want to prefer asynchronous communication. So SQS provides you asynchronous communication. Sometimes, let's say an object is uploaded on S3. You'd want to get an email, or you'd want to receive a notification. In those kind of situations, you can go for SNS. SNS is simple notification service. So what we are talking about are high level, some of the important services which are related to setting up your applications. One aspect which we did not talk about until now is the DevOps aspect, right? So whenever we talk about applications and whenever we talk about deploying them to the cloud, DevOps becomes really, really important. You'd want to automate everything related to provisioning of your infrastructure, deploying your application, and all the things related to that. And that's what is typically called DevOps. Whenever we talk about DevOps, we talk about a lot of things, right? We talk about continuous integration, continuous deployment. We talk about infrastructure as code. How do you automate the creation of your infrastructure? How do you automate the configuration of your virtual servers which are created in the cloud? And we also talk about observability. We would want to be able to see what's happening in your infrastructure. You want to be able to get metrics, logs, traces, and all those kind of things, right? Let's quickly look at all the services which are related to that. If you want to do CI/CD, if you want to do DevOps in AWS, the service is AWS Pipeline. You can use AWS Pipeline to create pipelines. There is also a service called Code Build, and we have a service called Code Deploy. So if you want to build a Docker image or a jar file or a WAR file, you can make use of AWS Code Build. And if you want to deploy it to Elastic Beanstalk, or if you want to deploy it to any other managed service which is present in AWS, or if you want to deploy it to EC2 instances, you can make use of Code Deploy. So you can make use of these two as part of your pipelines to deploy your applications in AWS. Now, infrastructure as code typically has two parts. One is provisioning the infrastructure. So let's say earlier we talked about creating a VPC, creating subnets, creating an application, maybe a EC2 instance or Elastic Beanstalk, and maybe creating a database, and then allowing them to talk to each other, configuring the rules related to that, right? So you need to create the infrastructure. You don't want to do that manually, because typically there are multiple environments: dev, QA, stage, production. The moment you do it manually, the chance that you make mistakes are very, very high. You don't want that to happen. And that's where you'd want to automate the provisioning of infrastructure. If you want to automate the provisioning of infrastructure, there are three different options. One is CloudFormation. CloudFormation is one of the first infrastructure provisioning tools which was provided by AWS. Basically, you write a lot of complex scripts to provision the infrastructure. Typically, these scripts, even for simple applications, can be running into thousands of lines. And that's where a cloud-neutral solution called Terraform became really, really popular. With Terraform, you can write simple scripts to provision your infrastructure. And an alternative which AWS provides now is something called CDK. In CDK, you can write Java programs, Python programs, or C# programs to provision your infrastructure. The other option you can also make use of in infrastructure as code is configuration management. What is configuration management? Let's say I have 100 VMs. I would want to install a security patch on them. Or let's say I have a lot of VMs on which I would want to update the application software. In those kind of situations, we make use of configuration management. If you look at the open source world, some of the popular ones are Ansible, Chef, and Puppet. And in AWS, the managed service is AWS Ops Works. So you can manage multiple VMs, you can install software, do a lot of things around that using your AWS Ops Works. So these are the things which are related to infrastructure as code. Now, when it comes to observability, typically we talk about a lot of different things, right? So we have tracing, we have logs, and we have metrics. CPU consumption or CPU utilization on specific EM, that's a metric. Logs which are coming from your applications, logs which are coming from your managed services, logs which are coming from your load balancers. These are all logs. Your applications might be going across multiple microservices, right? So your requests can be going across multiple microservices, and that's where you would want to trace the request across multiple microservices. Just having a piece of log might not be sufficient. What I would want to be able to do is to use that piece of log and to be able to trace the request across multiple microservices. That's where tracing becomes really, really important. In AWS, the service for metrics and logs is AWS CloudWatch. So AWS CloudWatch is for metrics, AWS CloudWatch logs is for logs. So this is a centralized place where you can send all the logs from your applications, from all the managed services in AWS as well. And metrics, all the metrics around your CPU utilization, your application related metrics, all of them can be sent to AWS CloudWatch. And for tracing, you can send all your tracing information to AWS X-Ray. This is the tracing service in AWS. Okay, those are some of the important aspects related to DevOps in AWS. The idea of this specific video was to give you a high-level overview around AWS. Typically, we are used to deploying applications in our data centers. I just wanted to take one of such examples and give you a high-level overview of how you can do things with AWS in a lot of high-level detail, right? It's not really detailed. I mean, we did not really set up anything manually. We did not create anything in AWS, but the idea was to give you a 10,000 feet overview of everything in AWS. I hope this was really, really useful. If you're able to make sense of at least 50 to 60% of this video, I think that's good success for me. And if you actually made, if 50 to 60% of this video made sense, then I think you are ready to go for a cloud certification. I would recommend you to check out any of our AWS, Azure, or Google Cloud certification courses, at least the beginner ones. Maybe something like Azure Fundamentals, AZ900, or even something like Cloud Practitioner, AWS Cloud Practitioner might be a good place to start. If you're going for Google Cloud Digital Leader might be a good place to start. Typically, if you are able to understand some of the stuff which is present in here, about 50 to 60% of the stuff which is present in this specific video, I think you can complete the cloud certifications in about 2 to 4 weeks. I was so confident that somebody can clear cloud certifications easily that I call my AZ900 certification as AZ900 in a weekend. So I call it Azure Fundamentals in a weekend. That's how confident I am that learning the cloud is very, very easy. So hopefully I made them as simple as possible. The goal was to just come on, like draw a picture, kind of make it easy for you to understand AWS. Because once you understand the big picture, once you understand things at the high level, you can dig in and find out things in a much, much easier way. And over the last few years, I've been working with AWS a lot. I thought it would be great if somebody can create something like this, which would be useful for beginners, especially if you are really, really beginner to the cloud, to get the high-level landscape of the cloud. So that's the goal of this specific video. I hope you liked it. I'm sure you had a great time watching this video. Do not keep it to yourself. Tell your friends and tell YouTube as well. How do you do that? Like, share, and subscribe. If you're looking to get cloud certified, check out our cloud certification courses in AWS, Azure, and Google Cloud. And do not forget to check out the other videos in this series of videos on cloud fundamentals. If there is a cloud topic that you're feeling it's very, very difficult to understand, do post it in the comments and we will make it simple for you. I'm sure you had a great time watching this video and I'll see you again very, very soon. Until then, here's bye from Ranga at In 28 Minutes. See you soon.